I'm going to insert it manually. AB, the graph will be like this, BA, the graph will be like this, okay. And then let's insert BC, okay. We insert BC. B already exists, right? Okay, remaining we just insert the C into here, okay. So we are going to insert C, okay. We insert C to here, and then we want to add a reference, okay. We add a reference C in here, okay. Because if we insert BC, right, then B will have reference of C, okay. B have reference of C like this, Let's we insert CB, okay. If we insert CB, then C would have reference, okay. C would have reference of B, okay. This B coming from here, okay. This B coming from here, and then after that is what? CB and then BD, okay. B have a D, okay. B have a D, okay. B have a D. Actually, suppose insert the orange color first. We are actually insert the orange color first. We insert the orange color, then only we add H. We add H in a D, okay. BD, and then we have a BB, okay. So our D have H, okay. Our D has the H of B, okay. And then CD, and then we have a C. C have a reference, okay. C have a reference of D like this, and then D, okay. D have a reference of C, okay. D have a reference of C. With this, okay, with this, right, we have finished constructed our graph. A have B, A have B, okay, correct. Our vertex A, okay, our vertex A have B, okay, vertex A have B. And then let's look at B. B have A, C, D, okay. B have A, C, D, okay. Our B have A, C, D, correct. And then our C have B and D, okay. Our C have B and D, this is correct also. And then our D have what? Our D have B and C, okay. Our D have B and C, correct? B and C. This is a truly very important part. This is called as breadth first search algorithm. First, you want to understand why do we want to do a breadth first search? Breadth first search is for traversing all the possible paths, okay. We want to visit, okay. We want to visit every node, okay. Our BFS, we want to take a vertex now, okay. We pick first, okay. We pick first. We do a pick first, okay. Our pick first will be our vertex now. Our vertex now is AL, okay. Our vertex now is AL, okay. And then we want to set it as visited, okay. If we set it as visited, we mark it as yellow, okay. We set A as visited, then this A also is visited because it is a reference, okay. It's a reference. Now we go to step 2. Step 2, right, we want to go to the vertex now. We go to the vertex now, right, in every adjacent, okay, every of the adjacent in the HR, okay, every adjacent in the H, we want to see if it's unvisited. Is it unvisited? If it's unvisited, right, we want to set it as visited and then put it to our queue and then print it, okay. This is a linked list, okay. This is a linked list. So if it's unvisited, right, okay, if it's unvisited, then we set B, okay, we set B as visited. If we set B as visited, right, then this B also will be visited, this B also visited, this B also visited, okay. So this B, after it is visited, right, we put it to the queue, okay. Our queue is first in, first out. Our B will be enter the queue, okay. We set the B to the queue, put it to the queue, and then we want to add the result, okay. We add the result. The result is like this, okay. The result will be, okay, we put A first, okay, because the A you see in here, right, the A is the vertex now, okay. The A is the vertex now. A, then only followed by the B, okay, the B. Then this is the blue color. B like this, okay. And then this is the result, okay. This is the result, okay. After we queue it, okay, after we queue it, right, we see, is there more adjacent? Is there any more adjacent? No more, right? Okay, there's no more adjacent. If there's no more adjacent, you go to the step 3, okay. Go to step 3. Is the queue empty? Is the queue empty? If the queue is not empty, okay. If the queue is not empty, right, our vertex now, okay, our vertex now is equal to dequeue, okay. We dequeue the B. If we dequeue the B, okay, we dequeue the B, right, we dequeue the B, our vertex now become B, okay. Our vertex now become B, okay. Our vertex now become B, and then we repeat, okay. We repeat it. We take our vertex now, okay. Our vertex now is B, okay. Our vertex now is B. Let's look at B have what adjacent. Our B have A adjacent, right? But A adjacent is already visited, okay. A adjacent is already visited. Then we go to the next adjacent, okay. We go to the next adjacent. This C is unvisited, right? Okay, this C is not visited, then we need to mark it as visited lah. Okay, we mark C as visited, then this C is also visited lah. Okay, we mark C as visited, then we want to put it to the queue. Okay, we put it to the queue, and then we want to add the result. Okay, we add the result. So it's going to be something like this. Okay, so it's going to be B and then followed by C. Okay, B followed by C, and then we go and check again. Okay, we check again. Is there any more adjacent? Okay, is there any more adjacent? There is, okay, there is, and this adjacent also not visited. Okay, adjacent is not visited, then we mark, okay, we mark this adjacent as visited. Okay, then we set D as visited, D is also visited, D is also visited, then we put it to the queue. Okay, put it to the queue like this. Okay, after you've done this, okay, after you've done this, right, every adjacent in the edge, okay, after you've done, because in the vertex now, we are dealing with vertex now, we are at this location, okay, our vertex now, after all the adjacent is visited, okay, all the adjacent is done now, okay, we done with all the adjacent, then this is our queue situation right now. Okay, this is our queue situation right now. So if our queue is not empty, okay, if our queue is not empty, right, our vertex now is equal to dequeue. Okay, you want to dequeue it. So we dequeue C. Our vertex now becomes C. Vertex now is equal to C. Then we go to C adjacent. Okay, we go to C. Is C adjacent already visited? C adjacent already visited. This adjacent also visited. Okay, if this adjacent is visited, then the queue do nothing. Okay, the queue do nothing. Then we move on. Okay, move on. Is the queue empty already? If the queue is not empty, right, what should we do? Our vertex now, we dequeue the D. Okay, so we dequeue the D. So our vertex now, right now, become the D. Okay, this will become D like this one. Vertex now become the D. Then you repeat. Okay, repeat. Graph BFS algorithm is so long. Okay, so long there is a adjacent. Okay, so long there is an adjacent, we just keep putting it to a queue and mark it as visited. After we mark it as visited, then we check is the queue empty already or not. If the queue is not empty, right, then we are going to dequeue it. We dequeue one time. We dequeue one time, right? Then we go to this vertex. Okay, we go to this vertex. Okay, we go to this vertex. Then we see. Okay, we see is the adjacent at the edge already visited already or not. If no, then we continue. Okay, continue add it to a queue. And this is the BFS algorithm. As you can see, okay, as you can see, right, in the end, okay, in the end of this vertices, right, all of the edge, all of the vertex, okay, all the vertex is fully visited. Our queue is totally empty already. Okay, if our queue is totally empty, we don't need continue. Okay, we don't need continue. Then we go to step 4. Okay, we go to step 4. Step 4 is we make all the vertex in vertices list as not visited. Okay, like this one. So you reset it. Okay, you reset just using step 4. Okay, step 4 will reset all the vertex. Reset all the vertex like this one. Reset A. Okay, reset A. And then reset B. Reset B. Okay, and then we reset B. And then we reset C. Okay, then we reset C. Okay, and then we reset D. Okay, then D get reset. Reset like this. Okay, this is the Graph BFS algorithm. Okay. First we take our A. Our A we mark it as visited. Okay, so our vertex now orange color. Our vertex now is equal to A. Okay, so our result. Okay, our result is like this. Our result will be like this. So first we have our vertex now is actually A. Our vertex now is A, and then we look at our A have what adjacent? A have adjacent of B. Okay, A have adjacent of B. Then we put it to a queue. Okay, put it to a queue. And then A have adjacent of what? A have adjacent of C. Okay, A have adjacent of C. We mark it as visited. But the way when you mark it as visited, right, it's actually written in here. Okay, A B like this one, and then follow comma, and then A, and then C like this one. Okay, and then lastly our A have adjacent of D. Okay, A have adjacent of D. We put it to a queue. Okay, so the result will be AD like this. AD like this. Okay, and then after we are done, right, A have no more adjacent. Okay, A have no more adjacent. Then we dequeue. Okay, we dequeue one time. We dequeue B. Yep, we dequeue the B. Okay, our vertex now is equal to B. Okay, then we go and look at B. B got what adjacent? B adjacent is A, visited already. Okay, B adjacent is E. Okay, B adjacent is E. Then we mark E as visited now. Okay, then we put it to Q. Don't forget to print. So B E like this one. Okay, after our B. Okay, after our B have no more adjacent. Okay, after our B adjacent is all visited, right? Then we are going to dequeue again. Okay, we dequeue our C. Okay, we dequeue our C. We dequeue our C. Okay, we dequeue our C. Then our vertex now is equal to C. Then we go to look at C adjacent. C adjacent is A. C adjacent is D. All visited. Okay, if all is visited, then we are going to dequeue again. Okay, we dequeue the D. Vertex now right now is D. Okay, our vertex now right now is D. Okay, then Then we go to D. D have what adjacent? D have adjacent of C, and D have adjacent of F. Okay. Then we put it to the Q. Okay. We put F to the Q. I will mark it as visited. Okay. So we write, don't forget to write D and F like this. Okay. Afterwards, okay, after our vertex now have all adjacent visited. Our vertex now have all adjacent visited, right? Then we DQ. Okay. We DQ the E. We DQ the E, and then our vertex now is equal to E. Okay. Our vertex now is equal to E. Then you look at E. E have what adjacent? E have adjacent of G. Okay. E have adjacent of G. Then we mark it as visited. Okay. Then we put it to a Q. Okay. Put it to a Q like this. Then don't forget to print it. Okay. E and G like this. And then when all the adjacent, okay, when all the adjacent of our vertex now, okay, when all the adjacent is visited, okay, visited, then we can DQ. Continue DQ the F. We DQ the F. So this is F. Okay, this is the F. And this is the F. Okay. So we look at F. F adjacent is visited, no problem. Then we DQ. Okay. We DQ again. We DQ. Then this becomes G. We go to G. G is visited. Okay, no problem. This is the result. As last algorithm that we want to check is called as depth first search. Okay, depth first search. And depth first search, how is it different? Okay, let's look at depth first search. Depth first search is using stack. To tell you simply, okay, to give you a simple answer. Depth first search is we want to explore the node. We see an adjacent, then we explore it. When we see adjacent, we explore it. Depth first search algorithm say when you see a node, okay, you see a node, you go to B. Okay, the next node is C, then you go to C. Then C have B visited, then you go to D. Okay. Right now, if there is nothing to trace, it's very hard. So that's why we use a stack. Okay, we use a stack to help us keep track. Okay, to simplify. Okay, to simplify the algorithm, like just now, if it's yellow, right, we will assume as visited. Okay, so depth first search say we take one vertex now. Okay, the vertex now is pick first lah. Okay, pick first. You pick first what is the vertices list. You pick first, you saw a A, correct or not? Okay, you saw a, and then you want to say it as visited and put it to us. Okay, you said the A is visited. A is visited. Okay, A is as visited, right? Then you put it to a stack. Okay, put it to the stack. So your vertex now is equal to A lah. Okay, your vertex now is A. Okay, your vertex now is the A right now. Okay, A lah. Okay. After we done step 1, okay, then we proceed to step 2. Okay, step 2. We take the vertex now. We take one only, okay, we take one only of the unvisited adjacent in the edge. Okay, we take the unvisited adjacent in the edge. If it is unvisited, right, we want to set it as visited. Okay, and then we put it to the stack, and then we want to add the result lah. Okay, add the result to here. Unless everything is visited. If everything is visited, right, then you are going to pop the stack. Can you follow? Unless everything is visited, okay, everything is visited, then we want to pop it. But right now, okay, not everything is visited. Not everything is visited, right? So what should we do? We want to set it as visited. Okay, so we set B as visited. Okay, B as visited lah. Okay, set B as visited like this one. Then we put it to the stack. Put it to the stack like this one. Okay, after we set it visited, we put it to the stack. Now we want to add result lah. Okay, we add result. So the result will be, okay, the result will be A, and then followed by B. Okay, B like this one. Like this one. Then after we done this, okay, after we done step 2, right, then we check if the stack is not empty. The stack is not empty, right? Okay, if the stack is not empty, then we want to vertex now is equal to pick. Okay, we pick the last one. Okay, we pick the last one. Okay, so this A, right, change on. Okay, we change it, become B. B. Okay, our vertex now is equal to pick last. Okay, we pick our last. This is the top of the stack. Okay, the top of the stack. But I didn't use stack lah. Okay, I didn't use stack. I used linked list. That's why I use a pick last. Okay, I pick last. Pick last meaning I look at B. Okay, I look at B. Okay, then we repeat step 2. Okay, we repeat step 2. We take vertex now. We look at the vertex now. We look at the vertex now, right? We want to get one unvisited adjacent. Okay, we look at B. We want to get one unvisited adjacent, which is C. Okay, which is C. Then we want to put it to the stack. Okay, we put it to the stack and then add the result. Okay, so we mark C as visited on. We mark C as visited, C as visited, C as visited on. Okay, so we put it to the stack. Okay, put it to the stack like this on. And lastly, okay, lastly don't forget, okay, write the result C on. Okay, then followed by B like this on. Okay, okay. Is all of the just now before we add it okay, just now before we add it, right? Just now before we add it is everything visited If everything is visited, then we want to pop, but our C is not visited, our D is also not visited, right? Then we don't pop it, don't pop. Then we continue. If the stack is not empty, okay, if the stack is not empty, our vertex now is equal to pick last. Okay, we pick last on. So this is okay, this is C on. Then we erase this one. Okay, we erase the B on. Okay, and then our vertex now is equal to C on. Okay, our vertex now is equal to C. Okay, our vertex now is equal to C. Then we repeat step 2. Okay, we repeat step 2. In C, right, we want to get one unvisited adjacent. Okay, in the edge, we want to get one unvisited adjacent. If it is unvisited, right, we want to make it become visited. Okay, we want to make it become visited, and then okay, add result. Okay, we want to add the result. Only if it's all visited, then we want to pop. But this is not visited, right? This is not visited. If this is not visited, we cannot pop. Okay, we cannot pop. We only should mark it as visited and then add it to a stack. Okay, so right now, we mark D as visited. If this D set as visited, then the corresponding D is also visited. Okay, so we add it to a stack. Okay, we add it to a stack, and don't forget, print it. Okay, print it. So D and then followed by C like this one. Okay. After we done this, after we done step 2, then we go to step 3. Is the stack not empty? If the stack is not empty, right, then we want to repeat. Okay, we repeat the step 2. Okay, our vertex now is equal to pick last. Okay, we pick the last node. The last node right now is D. Okay, the last node right now is D. The last node right now is D. Okay, let's write D. Okay, our vertex now is equal to D. We pick only. Okay, we pick only D. Okay, then we repeat step 2. Okay, is the vertex now, is there any unvisited adjacent? If there is unvisited, then we want to say as visited and then put it to a stack and then add the result. But if all is visited, right, we want to pop it. Okay, then we want to look at D. We look at D. Or D adjacent is all visited. If D adjacent is all visited, then we pop it off. Okay, we pop D off. Okay, we pop D off. Okay, then we go to step 3. Okay, step 3. If the stack is not empty, okay, if the stack is not empty, right, our vertex now is equal to pick last off. Okay, pick last the C off. Then we can erase the D. Okay, we can erase the D. Okay, so right now we pick last. Okay, we pick last. This is C off. Okay, this is C off. Then we repeat the cycle again. Okay, we look at C. We look at C. If there is one adjacent, or okay, if there is any unvisited, okay, if there is any unvisited, we want to say as visited and put it to a stack. Okay, and then add result. But if all is visited, okay, if all is visited, we want to pop it. We look at C. Okay, we look at C. C is all visited, right? Okay, if C is all visited, then we can pop it on. Okay, we can pop it like this on. And then we repeat. Okay, we repeat on. Our vertex now is equal to pick last on. Okay, we pick the last one, which is B on. Okay, which is B. And then our vertex now is equal to B. Okay, B like this one. Then we repeat step 2. Okay, repeat step 2. We go to B. Is there any unvisited? If there is no unvisited, right, we want to pop it. Okay, if our B there is no unvisited, then we pop our stack on. We pop our stack like this one. Our stack. Okay, we pop our stack like this one. And then we continue step 3. Okay, step 3. If the stack is not empty, okay, if the stack is not empty, right, our vertex now is equal to pick last. Okay, then we pick last on. Erase this one. Okay, our vertex now is equal to pick last. Okay, we pick last the A. We pick last the A. Okay, we go to A back. We go back A. We go back A. Is there any unvisited node? Okay, if there is no unvisited node, right, then we pop it. Okay, we pop it on. Then we pop the stack. Okay, if we pop the stack, okay, then our stack would look something like D. Okay, we pop the stack like this one. We pop the stack. If the stack is not empty, then only you want to do this. Okay, but our stack is empty, right? Okay, our stack is empty. Okay, then we can proceed to step 4. Okay, step 4 is we want to make all the vertex in the vertices list not visited after the stack is empty. We reset. Then we reset A. Okay, we reset A. Reset A. And we reset B. Okay, reset B. Okay, reset B. And this then we reset C. Okay, then we reset C. Okay, and then we reset D. Okay, reset D. Reset D. Reset D like this. With that, we have done our depth first search. Okay, this is the depth first search algorithm.